frustrating as it is, you do need to know the exact values of some uh, trig values, basically. So the answer here is root 3. You can skip on if you already know how to do that. Otherwise, I'm going to give you sort of two ways of remembering it. Method one is to actually learn how to derive it from scratch. And this is what you do. We're interested in tan 60, so I'm going to need to make an equilateral triangle with equal sides, and I'm going to make them 2. This is a sort of, you don't have to make them 2, you can make them anything, but 2 makes it work out nicely. I can then, so that's 60 here, that's by 30, I don't know why. Okay, I've drawn a line down the middle, which makes a right angle, and then this angle here must be 30 degrees. Not really bothered about that one. Actually, I'm going to leave it off because it might just complicate things. So if I want tan, I need to think about the opposite over the adjacent of this triangle now that I'm outlining in red. I know that this length is 1 because it's half of 2. So that just means I need to work out this height. And we can use that using Pythagoras' theorem. It's going to be 2 squared minus 1 squared square rooted. It's going to be root 3. And finally, I get my tan 60. Tan 60 is the opposite over the adjacent. It's root 3 over 1. It's root 3. Quite a lot of effort to just get that 1 mark. The expectation is you've learned the values. A bit frustrating. I personally prefer questions that say, like, show why tan 60 degrees is root 3, but hey, I didn't write the exam. So if let's say this made no sense and you just want to learn the values, okay, here's a little technique for doing it. So we can write down, these are the key angles you need to know it for. First of all, you need to know it sine, cos, and tan. Remember it in that order. And then the key angles are 0, 30, 45, 60, and 90. And here's a little algorithm. What we can do is we can write down 0, 1, 2, 3, 4. We can then square root each of these. There's no real maths going on here, we're just learning a memory technique. And this gives me the exact values of sine for all these different values. Okay, that's what the S stood for, sorry. Because I do exactly the same thing, but I do it in reverse. 4, 3, 2, 1, 0, square root, divide by 2. And tan, to be fair, is probably the trickiest one. What you do is you do part of the sine one, so 0, 1, 2, 3, 4. We square root it. And then we actually divide by, we don't divide by 2, we use part of the cos. We do 4, 3, 2, 1, 0, and we divide by those, but we square root these bits here. Okay, and finally, that gives us tan 60. It's root 3. Awkward, but there we go, because you need to use this value in the next bit. So these 4 marks are going to rely on it. You might get some method marks if you just, to be fair, if you used your incorrect answer, but you are going to lose an answer mark. So let's roll with it. Find the exact area of this triangle. Okay, we need to work out, it's going to be half base times height, so we need to work out this one here, which I'm going to call x. And we can remember that tan 60 is the opposite, so I'm using TOA here, opposite over adjacent, so it's going to be x divided by 4 root 3, and that means x is equal to 4 root 3 multiplied by tan 60. See, I could still get some marks even if I'd forgotten what tan 60 was, but I know what it is because I've got it here. It's root 3, so it's 4 root 3 times root 3, and actually that root 3 times root 3 becomes 3, so it becomes 12. And we've got our 12 here, and therefore we're nearly done. The area is equal to half base times height, so a half times 4 root 3 times 12, nearly there. What I can actually do is I can do half of 12. I can do the multiplication in any order I like, so it's just going to become 6. So it's 4 root 3 times 6, which gives me 24 root 3 centimeters squared.